Hey everyone. In this video, we're going to look at this example number 4. We have a weighted coin, so that heads comes up 90% of the time. So our success here depends on the way the question is worded. So in part A, we're asked to find the probability of getting exactly 4 heads. So since we're looking for getting a head when we flip the coin, then a success is considered getting heads. So again, it's good to write down what X is, what N is, and what P is. Remember, X is the number of successful trials. In this case, we're looking for 4 heads exactly. The number of trials that happened are 10. And the probability of a success, in this case, since it's a weighted coin, is going to be 0.9. Probability we get heads is 0.9 because the coin is weighted so that heads comes up 90% of the time. So if I'm going to find the probability of getting exactly 4 heads, I'm going to use my Binom.DIST function, which takes 4 arguments, the number of successes, X, comma, the number of trials, 10, which is N, the probability of success, that's 0.9, that's our p-value, and then do we want cumulative or do we want the mass function? We want false here because we want exactly, we don't want it to be cumulative, we want exactly getting 4 heads. And that comes out to 0.0001378. Okay. So the probability of getting exactly 4 heads when we flip a coin 10 times that is weighted so that usually heads comes up a lot more is pretty low. Now let's find the probability of getting less than 2 heads. All right, so the probability of getting less than 2 heads, again, we have our X, our N, our P. P is still 0.9, N is still 10. But in this case, we want to get less than 2 heads. So we actually want less than or equal to 1 head. So less than 2, the only numbers that are less than 2 when thinking about discrete variables are 1 and 0. We could get 1 head or we could get no heads. So we want less than 1 here. And so we're looking for the probability of getting less than or equal to 1. That'll be the same thing as getting less than 2. And I'm going to use my binomial distribution function again, binom.dist. Number of trials is 1. N is 10. I can just type this in. I can reference the cells. In this case, I can't reference this cell because I put a less than or equal to in there. But I can reference this cell, and now because I want it to be cumulative, I want it less than or equal to 1, I'm going to say true. So this comes out super small. What is 9.1 times 10 to the negative 9, which is what this is saying? That's the same thing as 0.000000091. So that's a lot of zeros. That's basically 0. The probability that I'm going to get less than 2 heads is 0. I mean, it's not 0, but it's pretty much 0. It'd be very difficult for you to flip a coin 10 times that's weighted so that 90% of the time it comes up heads, and for that not to happen, at least for that to happen less than 2 times, it's pretty much impossible. It's not impossible. Given enough time, anything is possible. But in this case, it's so small that it's basically 0. All right, now let's do the probability of getting 7 heads or more. So we want 7 heads or more. So this is going to be 7. Actually, it's going to be 6. Because if I want to get more than 7 heads, including 7, then the opposite would be getting 6 or less. So we're going to calculate the probability of getting 6 or less, and that will help us find the probability of getting 7 or more. So x is going to be 6, n is going to be 10, p is going to be 0.9. So what I'm doing here is I'm trying to calculate the probability of getting greater than or equal to 7. So that's the same thing as 1 minus the probability of getting less than or equal to 6. So I'm going to calculate the probability of getting less than or equal to 6. Using my binom, because this is the way the binomial distribution works. I can't make it calculate something that's greater than or equal to a value. It always calculates less than or equal to a value. I just have to work within those confines. And so I'm going to use 6, 10, 0.9, true. And that comes out to 0.0127952. So the probability of getting something that's greater than or equal to 7 is actually 1 minus this number. 1 minus this number. So we have a 98.72% chance of getting 7 or more heads. So let's do the same thing. We're going to find the probability of getting over 8 heads. So that is the wording. You got to be very careful here with the wording. Notice how our n, our 0.9 for p, that stuff's not changing. It's the x that's changing. We want to get over 8 heads. So that means x is going to be actually 9. So I don't want to include 8 here. I want to include 9. So I want the probability that x is greater than or equal to 9. And that's going to be 1 minus the probability that x is less than or equal to 8. So I guess for the thing that we're calculating here, x is going to be 8 because we have to calculate what's less than or equal to. So the probability of getting x is less than or equal to 8 is going to be Binom.DIST 8, 10, 0.9, true. And then the probability that we get over that is going to be 1 minus this answer. So again, we have a 73% chance that we're going to get over 8 heads. All right, last example for this problem. Find the probability of getting tails less than 5 times. All right, so our idea of a success has now changed. Now getting tails is successful. Because of the way this is worded, we want to get tails less than 5 times. So x is going to be 4 because it's less than 5. It's not less than or equal to 5. N is still going to be 10. But P now, the probability of success is going to be 0.1. Because the probability of success normally is 0.9 for heads, but this is tails. And so the probability of success and failure have to add up to 1. So if the probability of failing in this case is the 0.9, that means the probability of getting tails has to be 0.1. And so we want to find the probability of x being less than 5, which is the same thing as the probability of x being less than or equal to 4, which in this case is going to be Binom.DIST. We have x, n, p. We want this to be cumulative. So you get a 0.9983